Hello students, coming to the next session of alloy steels. So alloy steels, why it is called as alloy steels and how it differs from plain carbon steel. Alloy steels contain some of the elements like nickel, manganese, chromium, vanadium, etc., which are added to plain carbon steel to improve the properties. So or improve properties such as give us more strength, hardness, toughness, wear and abrasion resistance. Again, provide corrosion and oxidation resistance and less cracking tendency than plain carbon steel. So that's why most preferably in various applications alloy steels are preferred. So before moving to classification of alloy steels, first we'll try to understand what are the effects of the alloying elements on the specific steels. So one by one we'll move on. Before that, so following are the elements which are added to the alloy steels. That is first one aluminum, which is a ferrite hardener. Second one chromium, which is a mild ferrite hardener. Cobalt, as again a high effect is provided on ferrite hardener. Next one molybdenum, which has a strong effect on hardenability, and all are graphitizers. Similarly, hardenability element as chromium, whereas strength is provided by most probably carbon and molybdenum nickel. Similarly, nickel again provides the toughness, and after that good machinability we get by sulfur. Next one, what are the effects of alloying elements? First one, hardness, strength and ductility. Aluminum is increased, aluminum increases the hardness, whereas all other elements are shown in the table. Continuing to alloying elements, first one we have sulfur. It is added less than 0.05%. Again, it sometimes is considered as an impurity. So when it is added, it increases the hardness and brittleness, whereas it causes hot shortness. That is, what do you mean by hot shortness? When it is, or when sulfur is added and the steel which contains sulfur less than 0.05%, at hot working conditions it produces crack in the steels. That is, cracking tendency of steels is generated due to the addition of sulfur, which is usually called as hot shortness. Next one, manganese is preferably added, which forms manganese sulfide and which reduces the tendency of cracking of steels and which increases the machinability. So it is used preferably in free cutting steels. Next one is phosphorus. Phosphorus is also added in between or less than 0.05%. Again, it is sometimes an impurity. It dissolves in ferrite and it increases strength and hardness. Again, it produces cold shortness. That is, it produces a cracking tendency when the steel is used for cold working. But it is preferably added to improve the machinability. Next one is silicon, which is a strong deoxidizer and a strong graphitizer. That is, it reduces the oxides content, that is preferably in keel steels. Similarly, it is a strong graphitizer which reduces the carbides, that is, it decomposes carbides into graphite. Next one we have manganese, which forms manganese sulfide and which important property it produces, that is temper embrittlement is generated. What do you mean by temper? When a reheat treatment of steels is done, there is a high brittleness increment when when steel is treated in between or nearby 400 degrees Celsius. So sometimes it is added in between 12 to 14% and which produces extremely tough properties and high wear resistant. Next one we have chromium, which is the very most important alloying element in stainless steel, because it increases the corrosion and oxidation resistance of the steel by forming a protective layer of chromium oxide. And again, there is a chances of temporary embrittlement if added in greater amount. The other properties, it increases about hardenability and it forms a carbide again. Next one we have nickel, which again increases strength, hardness and toughness. But important characteristics of addition of nickel is increases the impact resistance of the steel, and again it reduces the thermal expansion of the steels. Example are inver, coefficient of thermal expansions 0, L inver, etc. Next one we have molybdenum. Molybdenum is again one of the carbide former. It increases the hardenability, but important property of molybdenum is it reduces the wear and abrasion resistance, and it refines the grain structure by forming a graphite former. Aluminum again is a very powerful deoxidizer, which is preferably used in killed or semi-killed steels, which removes oxides, and again it refines the crystal structure. So following are the summary of the alloying elements, that is nickel, molybdenum, vanadium and aluminum. And whereas effect on the steels, that is lower the coefficient of thermal expansion by addition of nickel, we have carbide former and hardenability is increased by molybdenum. And vanadium, when added, it forms hard or extremely hard carbide, and when aluminum is added, it produces very strong deoxidizers. And what are the remarks of addition? That is high temperature applications of nickel reduces temporary embrittlement when molybdenum is added, and vanadium is a strong deoxidizer. So, and one important point about the alloying element is alloying, when intentionally alloying elements are added, or when an element is added intentionally, we call it as an alloying element. But when it is not intentionally added, we call it as an impurity. So this difference between two, that is alloying elements and impurity, is to be remembered. Thanks for today's session.